Hello, it's Stat 135, Lecture 35. Last time we talked about simple linear regression, and we saw that beta 0 hat and beta 1 hat are normally distributed, unbiased estimators with the variance shown in the highlighted formula. The covariance is also given here. Hypothesis testing in simple linear regression. We provided a 95% CI for beta 1 and beta 0. And we saw an unbiased estimator for sigma squared is RSS over n minus 2. RSS is the residual sum of squares. Today we're going to further talk about simple linear regression with an example and talk about the standard error of the regression line and a confidence interval for the Tyche line. This material is not in the book. So here's an example. The speed and stopping distance of 50 cars was recorded in the 1920s. The dataset cars contains two columns, speed and distance. So a linear regression model was run to predict the stopping distance of cars from its speed, and the result in R are shown. Some values are missing. So what we see, the estimate for beta 0 hat and beta 1 hat, the standard error for these beta 0 hat, beta 1 hat, the t-value, that's with n minus 2 degrees of freedom, and also the p-value. But we'll talk more about hypothesis testing later. We have the residual standard error, which is RSS over n minus 2. And you can just ignore the rest of this for right now in this readout, except for you'll need the mean for distance speed and the SD for speed. So first we calculate A. So we know that the t statistic is minus 2.601, and that's beta 0 hat minus beta 0. Beta 0 is 0, so that is the null assumption, and the standard error. The standard error for beta 0 hat is what is A here. So we can just solve for A, 6.76. Then we can calculate the missing value B and interpret this slope coefficient. So here we have lots of information. We know the mean of X and the mean of Y, and beta 0 hat. We can just plug that in and get beta 1 hat, so 3.63, and you can interpret a 1 unit mile per hour increase in speed is associated with an increase of 3.93 units in feet in stopping distance. That's an interpretation of what the 3.93 is. And then furthermore, we can find C and D. So the residual standard error is which is sigma hat, is the square root of RSS over n minus 2, which is 15.38. So we calculate C first. So C is the standard error of beta 1 hat, and so that's squared, which is the variance of beta 1 hat. We know that's sigma squared over n variance of X. I've written out an approximation for this using sigma squared hat, and I've written n times the variance as the sum of xi minus x bar squared. And so we know what the sum is. It's n minus 1. It's n minus 1 times the the sample variance provided by R, which has n minus 1 in the denominator, which is why we're multiplying by n minus 1. Here n is 50, and the sample variance we found was 5.29 squared. So we can calculate then C is 0.42, and calculation of D is completely similar. So now we're going to talk about the standard error of the regression line. This is not in the book. So there's something that I want to caution you here, and that is that it's important to understand that in the standard statistical model, that the xi is fixed. It's not a random variable. So the way to think about this is that you collect data x1 to xn. These are fixed numbers. Then Tyche gives you numbers y1 to yn by applying the formula yi is beta 0 plus beta 1 xi plus ei, where ei is normally distributed 0 sigma squared. So the y1 to yn are random variables. Every time you give Tyche x1 to xn, it'll give you out another y1 to yn. And so so every time given you x1 to xn, you get a different regression line. Okay, and we're going to find the SE of that regression line. Okay, so now so we need some notation here. So y hat is the predicted value for a given x. So x is allowed to be one of your data points, x1 to xn. And so yi hat is beta 0 hat plus beta 1 hat xi. This is the predicted response to xi in particular. Okay. And the expectation of y given x is beta 0 plus beta 1x. This is the Tyche line, where here x is a predictor random variable. So x can take here I1, x can take here any of our original data. So that's x1 to xn. So that is a value on the Tyche line. Okay, so I've made a picture here with three data points, x1, x2, and x3, and I've drawn the regression line and the Tyche line, and in particular for x2, I've written out the y2 hat on the regression line. The expectation of y given x is x2 on the Tyche line, and y2, which is in black here. So the expectation of yi hat is beta 0 plus beta 1 xi. So yi hat is an unbiased estimator of the expectation of y given x is xi. And furthermore, you can write yi hat as y bar plus beta 1 hat xi minus x bar. So if we take the variance of that, we get three terms here. The variance of y bar, the variance of beta 1 hat, the xi minus x bar is a constant and pulls out as a square, and then a covariance term, which turns out to be 0, as I've worked out for you here in orange, and I won't go through those details here. So the variance of yi hat is sigma squared over n plus xi minus x bar squared, sigma squared over n variance of x. And so we can rewrite that as the highlighted formula here, and notice that this is for I 1 to n. So this variance is for those yi hats on our regression line that come from our original data. And the standard error then of yi hat is in the formula below. So I've made a picture here. And so for xi, so this is one of our original data points, where we have here a confidence interval. We have a confidence interval for the for that point on the Tyche line corresponding to yi. So I should write that here. And so also notice from the standard error here that the closer that xi is to x bar, the more certain we are about the value on the Tyche line. Expectation of y given x is xi. So if xi is x bar, then the variance of yi hat is the variance of y bar, which is just sigma squared over n. Otherwise, it's bigger. And a confidence interval for the Tyche line, from above, we have that a 95% confidence interval is yi hat plus or minus, so the cutoff tn minus 2.025 times the standard error, where the standard error is in this highlighted formula that we derived above. And just to reiterate, this is for our original data. I is a number between 1 and n. So the CI is only for points on the Tyche line. Expectation y is x is xi, for I is 1 to n, our original data. Okay, so have a good day, and I'll see you next time.